So here's a simple example of an S3 class and method. So in the top here, I'm generating some random normal data, and I'm calculating the mean. So here the mean is minus 0.0307. So that's not particularly complicated, but there's actually a lot of stuff going on behind the scenes. And so first of all, the class of x, which is this random normal vector, is numeric. So I call the mean, which is a generic function on this numeric vector. It will search to see if there's a specific mean method for numeric objects. But there is no, as it turns out, there's no method for a numeric object, so it will call the default function for mean, which calculates the sum of all the elements and divides by the length of the vector. So you can look at the default method for the mean function by using the getS3 method function. And you can see that there are other arguments. There's this trim argument, na.rm. And as you go through the function, you can see that it checks a number of things. If you're doing a trimmed mean, it takes care of that first. And then ultimately at the very bottom, it calls some internal C code that actually calculates the mean for efficiency purposes. So that's the mean is a simple example. Here's a slightly more complicated example. I've generated some data in a data frame now, and I'm applying the mean function over the data frame. So one of the things that is important to know about data frames is that each column could potentially be of a different class. So you could have the first column be numeric, like we have here, and then the second column be integer. So when we apply over the columns, and we call the mean function for each column, the mean will check the class of that column and see if there's an appropriate method. So for the first column, it's numeric. It will check for a numeric method. There isn't one, so it will call the default. And then the second column is actually integer, so it will check for an integer method. Again, there's no integer method, so it will call the default for that column too. So if you have a large data frame and every column is a different class, the mean function will check each column to see if there's an appropriate method for that class. So in some cases, it's possible to call a method directly. So for some S3 methods are visible to the user. So for example, the mean.default function you can possible to call that directly without actually calling the generic function. But in general, the rule is you should never call methods directly. You should always call the generic function and let the appropriate method be dispatched automatically. And this results in cleaner code. And slightly more robust. That way, if the name of the method changes a little bit, you won't have to worry about the underlying details. With the S4 system, this isn't a problem because you cannot call the methods directly for the most part at all. So one last method example for an S3 class method. So here's the plot function, and I'm generating some random normal data. So when I plot it, again, it looks for a numeric method for plot. Since there isn't one, it just calls the default method for plot, and it makes a little scatter plot, as you probably would expect. However, this is a slight variation. I'm generating some random normal data, and then I'm converting it into a time series object. So I use the as.ts function to convert it into a time series. Now you'll notice I call plot exactly the same way as I called it in the previous slide. But now you can see the plot is totally different. Instead of a plot with a bunch of circles on it, it actually creates a time series kind of plot where all the kind of lines are connected. And also you'll notice on the x-axis there's a label on it called time. Which is different from the x-axis that was called for the default function in plot. So here you can see that there is a special plotting method for TS objects, or time series objects, and that plotting method is actually being called here, not the default method. So if you want to write new methods for new classes, often if you create a new class to represent a new data type, you'll probably end up writing methods for printing or showing. You may write a method for summary. You'll write a method for plotting because there won't be a plot method for a new type of data. And so there are two basic ways that you can extend R with the classes and method system. You can create a new class and then write a method for an existing generic function like print or plot. Or you can write new generic functions and new methods for those generics for your new class. So for the rest of this lecture, I'm going to talk about S4 classes. And so one basic question is, why would you want to create a new class? right? So what's wrong with vectors and lists and numerics and integers and logicals, etc. And while it's possible to survive on just the basic data types, often it's easier and more compact to think of, at a higher level about more complex data types. So for example, you might want to represent new types of data like gene expression data, spatial temporal data, hierarchical data. So you might want to represent a sparse matrix. These are all data types that don't exist in R. And so you have to create a new class to represent them. There are often new concepts that haven't been thought of yet. So you can think of like, there's a linear model type of class, but you can think of point process model as a different kind of class. A mixed effects model is another type. So things like that haven't been thought of, that haven't been kind of implemented yet in R. And also, you might want to hide certain implementation details from the user. And so you may be able to kind of represent a new type of data using lists and vectors, but then there may be a lot of ugly details that are exposed to the user that you would rather not the user know about. And one thing to emphasize, that when I say creating a new data type, I don't necessarily mean that the data type has never been seen before. All I mean is that it's not known to R, and R doesn't have any special handling for those data types. So creating a new class is done with the set class function. At the very minimum, you can get away with just specifying the name of the new class, but often when you specify a new class, there will be data elements associated with this class, so these are called slots. And then you can define methods for this class using the set method function. So at a loose level, you can think of a class as like a list. Every class has a bunch of slots, so these are kind of like elements of a list. But each slot, it's a little bit more specific because each slot is an object of a certain class. So you can't just put arbitrary data into any slot of a class. You have to put the specific type of data into each slot of a class. So for example, here, I have a simple example of creating a polygon class. So there's no polygon data object in R. So you can think of a variety of ways in which you might represent polygon data. So you can think of a polygon as a set of vertices and a set of, or it's just a set of vertices, and thinking, kind of lines connecting the vertices. So here I'm creating a polygon class, and in the representation, I create two slots. One is called X, which contains the X coordinates of all of the vertices. And then another slot is called Y, and that contains the Y coordinates for all the vertices. You can see that. So I specified that the X and the Y slots are to be numeric values. So if I create a polygon object, the X and the Y slots have to have numeric data. They can't have characters. They can't have integers, etc. So now I've created a polygon class. The next thing I probably want to do is create a method for example, for plotting a polygon. And so when you call the set method function, you have to specify a generic function such as plot, and then you have to specify something called the signature. And so the signature is basically the set of classes on which the generic on which the method will operate. So in this case, I want to create a method for the plot generic function, and the signature is basically going to be this polygon class that I just created. So here's my method for the plot generic. I call the set method function. The first argument is the name of the generic, and the second argument is the signature. In this case, it's polygon. And so you can see in this function, I takes an X and a Y argument, and then the dot is for kind of other arguments. And so you can see that so the X argument is just the polygon object. The Y argument is missing. There's no Y argument here. And so I can see that within the function, I actually call plot again, right? So here, I'm creating a method for the polygon object, and then within the method, I actually call plot again. But then that's going to be the default method for plot because I'm just plotting some numeric vectors in that case. So what this function does is it plots the vertices, and then it sets to set up the plotting window, and then it kind of wraps the vertices around themselves so that they kind of connect. And then it uses the lines functions to connect the dots. And then that makes my little polygon here. And so that's the plotting method for polygon objects. And you'll notice that the plot, since plot already existed as a generic function, I didn't have to create a new generic function. And notice that when I want to access the slots of an object in an S4 class, I use the @ symbol. So it's kind of like a list, but instead of using the $, I use the @ symbol. So after I call the set method function, if I call show methods on plot, you can see that the polygon method has been added to the list here. And then in addition to the polygon method, there's also this any method, which is the default method. So here I'm creating a simple polygon. I'm using the new function to create a polygon, an object from the polygon class. I create the x vertices and I create the y vertices. And now when I call plot on it, you can see that it doesn't just call the default plot method. It actually calls my method that I just created. And you can see it draws this little triangle by connecting the dots. So that's a very simple example on how to create a new class and develop some new methods. In general, developing classes and methods is a very powerful way to extend the functionality of R. And so just to summarize here, classes define new data types, so they allow R to represent new types of data. Methods extend generic functions to specify the behavior of generic functions on these new classes that you developed. As you develop these new data types and these new concepts and make them familiar to R, the classes and methods give you a way to develop kind of an easier interface for users to kind of interact with new types of data. And so it's really a handy way to kind of create new data, to allow users to interact with new kinds of data without having to get bogged down in a lot of the implementation details. And one of the most popular ways to kind of make new classes and methods available to users is through R packages. And so most commonly you'll see these types of things embedded within an R package.